So welcome to exam 1 review session. In this review session, we're going to talk about the intro, the chem, cells, tissue, which is also known as the histology, and then the integumentary. Some basic information. In terms of content, the lecture will be on all those chapters that we talked about. So intro, chem, cells, tissue, and integumentary. So there's 5 chapters. There's 50 test questions. So guess how many questions are on each chapter?
15? Sorry, I didn't hear the question. Well, question again.
That's okay. So there's 5 chapters,
Uh-huh.
50 questions. So how many questions do you think will be on each chapter?
10?
Yep,
Yes.
that's exactly it. That's exactly it. So we divide the questions equally amongst the chapters. Okay. So sometimes students ask me, okay, which one are you going to focus on? None. You know, we try to divide equally amongst the chapters. So that means there's 10 on intro, 10 on chem, 10 on cells, 10 on tissue, 10 on integumentary. Okay. So that means that you really want to study all 5 chapters equally. Okay. So that's for the lecture. Then for the lab will have the intro, which is all the terminology, the cells, and the histology. Those are all the slides. And you ask a lot of questions about them. So that's great. So make sure you listen to all the questions and kind of are aware of the answers to them. Okay. In terms of time frame, unless you have special accommodations, the lecture exam has 50 questions and you have 50 minutes. So 1 question per minute, or 1 minute per question. Of the 50 questions, 40 of them are going to be multiple choice and 10 of them will be short answers. You have to type in the answer. Okay. The first 40 is going to be very similar to your quizzes, all multiple choice. Okay. And then the last 10 will be short answers. You'll read a question and then you'll type in your answer. Okay. They will appear, multiple choice questions come first, and then the last 10 questions are the fill-ins. Okay. So when you see the exam, the first set of questions will be all multiple choice. The first 40 questions will be multiple choice. They are lumped by chapter. So the first 8 questions will be on intro. The next 8 questions will be on chem. The next 8 questions will be on cells, tissues, and integumentary. Okay. Then you'll come to the 10 short answer questions. The first 2 will be on intro. The second 2 will be on chem. The next 2 will be on cells. The next 2 will be on tissue, and the next 2 will be on integumentary. All right. Then for your lab exam, you will have 30 questions. All of them are identification. They're all write-in. There is no word bank and spelling counts. So what you did and it's exactly like your lab quizzes. Okay. So how you saw your lab quizzes, your lab exam is going to be the exact same way. You're going to see an image, or you're going to see a term, or, some definition, and then you'll fill in the term, or you'll identify what structure that is. Spelling counts. You didn't have a word bank for your quizzes. You won't have a word bank for your exam either. Okay. So for yeah, go ahead.
Sorry.
No, go ahead. Don't ever apologize for asking questions. Go ahead.
For spelling, so say we're off by like 1 letter, would we get that whole answer incorrect, or do you take away the points by like the amount of like spelling and errors we have? I'm not sure how that's.
It's exactly the same as your quizzes. So you'll notice that your quizzes, sometimes you may be off by a vowel. Sometimes you'll be off by a consonant. Sometimes you'll be off by a few. As long as I can recognize the word, you'll get credit for the word, but you'll get 0.5 off for the spelling.
Okay, thank you.
But I have to be able to recognize the word. Like, okay, I know what they're trying to get at. Sometimes, students maybe have the correct first letter and everything else is wrong. I can't recognize that. So you won't get that one. Okay. And it is based on my judgment. So if I can recognize it, and I'm, usually very, very wide range in terms of like, okay, I can recognize it, even though like there's a lot of spelling errors. As long as I can recognize it, I'll give you 0.5 for it. Okay. For both lecture and lab exam, the questions appear one at a time. and you can move back and forth, but I don't recommend it. Okay, and the reason for that is because when you move back and forth often, you will lose the place where you're at. Plus, the more, you put through the computer to have to kind of process, the more technical errors that can occur. So it's best to start from, wherever you start and go all the way through, and then go back to the ones that you kind of are marked or saw that you didn't complete, and then do them. So spend the right amount of time that you need to on each question, answering it fully, and then move on to the next one. And then the next one and the next one. And then once you've completed all of it, then go back to the questions that you had questions about. Okay. Do you have any questions? Okay. No one's asked me, but you should know that I do allow a blank piece of paper. Okay. So you are allowed to have a blank piece of paper when you're taking your exams. Okay. Now, during your environmental scanning, you just have to show me front and back that is blank. This one's not blank, it has a drawing on it, but show me both front and back before you take your exam during the environmental scan. And then once you're done with the exam, you also want to show me front and back what you have on it. Okay. But you are allowed to have scrap paper so that you can jot down things or kind of note which question you want to go back to. Any questions so far?
For the video you put in the email, I saw that I emailed you about this too. The lady has a mirror on the back, but if
Yes.
we have a big mirror like that, would you want like another alternative, or just that we do it very good through environment scan?
Well, I thought I replied to you. Did I not yet?
Sorry?
Did I reply to your email? I thought I did.
You said you were going to talk about it here.
Okay. All right.
Yeah.
Okay. I thought I also told you what I was expecting, but that's okay. So with your camera, essentially what I just need to know is that around you, there's nothing. My table right now is not a great example because I have so much on there, but your table should be clear. There should not be any cell phones, anything except for your laptop or your desktop computer. Okay. So essentially, this is what I'm looking for.
Okay.
I should put it out a little bit more. Okay. So it's just to show me that there's nothing around you or near you.
Okay. Sounds good.
You also want to make sure that, there's nothing on your lap, because in previous years, I've had students put their cell phones on their lap, and I can see when you go like this for extended period of time. And plus, when you have your phone on, do you see how it flashes on my face? Do you see that?
Yes.
Yeah, that's how I know you have a phone in front of you, even though I don't see the phone.
Okay.
Okay. And there's other ways too. I mean, just if you are not doing anything wrong, you have nothing to be afraid of.
Yeah.
Okay, so just don't have anything around you. Don't have your phone near you or any other device. It should only be you and the device you're taking the exam on. Okay.
Okay. And for
Mhm, go ahead.
for example, like the paper when we're writing things down, do I tell you in the camera like, oh, I'm writing this down?
Nope.
Okay.
Nope. Because that's why you do the environmental scan initially, right? To show me that there's nothing around you except for that piece of paper.
Okay. Okay. Sounds good.
Exactly. Yeah. And it's not for me to intrude into your space, but it's just to protect you if respondents does flag you.
Yeah.
And then I can just say they're not cheating because they showed me their environmental scan. There's nothing around them. There's nothing on their lap. I'm 100% sure this person was not cheating.
Okay.
So I'm just gonna go, oh, perfect. Pass you
Okay.
through.
Sounds
Okay.
good.
Can I ask another question?
Yeah.
So the desk I have at my house also has my boyfriend's PC on it, and I can't take it off the table. If I
No
just show
worries.
that it's completely turned off, is that okay?
Yes, ma'am.
Okay.
Yep. Yeah. Other questions? All right. So logistically, you'll need to have respondents lockdown and the webcam. Okay. Your exams unfortunately will not be graded unless you have a complete and thorough environmental scan. The scan is meant to protect you. Response requires me to watch your video if it detects, academic disintegrity. And then I have to watch it. I have to show that you weren't, that you were doing just fine. And then I click on a button that you're approved, and then your exam scores show up. Okay. So during your exam, your full face must be on the screen the entire time. Sometimes students go like this. Okay, where I'm only seeing the ceiling, or I'm only seeing a part of their head, or I'm seeing just like here. All right, so I need to see your face. Otherwise, the respondents lockdown is going to flag you. So you want to make sure that you're far enough so that your whole face can be on the screen. And it's just to ensure that whatever direction you're looking at, you're kind of focusing on that instead of like looking over here or looking over there. Okay. What else? If you are caught, I will always talk to you first. If response lockdown flags you and there was academic disintegrity, detected, then I will always talk to you. So please don't avoid me. Please respond. We will talk about it, and then we'll go from there. Okay. So hopefully I won't have to talk to anyone. Troubleshooting, try out the practice quiz. The practice quiz you can take as many times as you want. And it's there to make sure that your computer is working with respondents lockdown and the webcam correctly. So just do it ahead of time. Make sure you have stable internet, because just remember, technical difficulties is not a valid excuse. If we're on an online class, if it's like you have a storm and the storm cut off your internet, that's out of your hands, that's something else. We'll take that into consideration. But the fact that, if, you just don't have reliable internet, then we would need to talk about, as you are taking a fully online course, what the implications of that would be. Okay, so just make sure that wherever you're taking the exam, you have reliable internet, your respondent is working, and you should test out the webcam function as well. Okay. If something should happen, don't wait until the last minute to take the exam. Okay. Stay calm and text me. You have my text number. You have my cell phone number. Texting is probably what will get me immediately. Don't email me alone, because I don't always check my email every minute. So it's really best to just kind of text me or give me a call. I'm going to check the chat. When you say short answer, we'll be defining a term or identifying a definition. Identifying a definition. For lecture, it could be identifying a definition, or it could be filling in a question specifically. Okay. All right. Recommendations. This is why I always have my review sessions really early on, so that I can recommend the 5-day study plan. I emailed you that kind of study format. So use the 5-day study plan, break the chapters up. Don't study all the chapters at once. It's a lot of information, and your brain will just come to the point where, it's not going to soak it anymore, regardless how much more times you look over something. Okay. So split it up so that you are handling it in small chunks at a time. When you're studying, make sure you stop, periodically check your understanding. In other words, did you just kind of read over it, or did you truly absorb it? Quiz yourself. Use test-taking strategies. And I'll go through examples of the test-taking strategies later on when we go through practice questions together. Study the oldest or the hardest material first. Okay, oftentimes students study the easiest, and then they leave the hardest material for the end, the last day, and then they run out of time. So they don't ever study the hardest material. So that's why I usually recommend study the hardest material first, and then study the easier stuff. Or you can study the oldest material first, and then to the newest. And the reason for that is because the older material, you're less likely to forget. Okay. Studying complete chapters, don't skip around. Like, don't do a little bit of epithelium and then go to cells and then move to chemistry. Study all of them, in one sitting. So for example, all the chemistry all at once. all of the cells all at once. So like on Wednesday, I would do all of the cells. And then on Thursday, I would do all of the tissues. And then on Friday, I would do all of so on, you know? So break it up, but study them together because then it's less likely to confuse and cross confuse things. Any questions? And it could be anything on the exams. Okay. If something does come up along the way, you feel free to ask in the chat or just unmute, okay? So we're going to start to do an overview of intro, chem, and cells today in this first session. And then in the ninth session, I'm going to do tissues and histology so that I have enough time to kind of cover everything. All right. So for introduction, make sure you know the chapter on scientific method, know all the terminology and all the definitions. And then be able to define what anatomy is and what physiology is. Sometimes it could be pure regurgitation. So for example, the study of structure is what? And you would say, the study of structure is what?
Anatomy.
Thank you. Anatomy.
welcome.
Thank you. Okay. Other times the question could be, okay, you're in a lab and you're looking at the heart. What are you studying? Anatomy. Okay. So it could be a pure regurgitation, like the word for word definition, or it could be an applicable question. Okay. Also make sure you know the levels of a hierarchy from smallest to largest, atom, molecule, organelle, cells, tissue, organ systems to organism. I could ask a question, for example, what is the smallest living structure? What would you say?
A cell.
Perfect. I could say, okay, between these four things, what is the largest of these four things? And I can say the heart, the endocrine system, epithelial cells, and carbon. Which of those is the largest?
Endocrine system.
Perfect. Okay, so you can see in that question is an application question and not a pure memorization question. Okay, so those are the types of questions you would expect on the exam. You will find a lot on homeostasis because homeostasis is going to be something that we touch on every single chapter. Okay, homeostasis is the ability to maintain stable internal environments. That's the pure definition. Okay, I could say, okay, which of the following is an example of your ability to maintain stable environments? So for example, body temperature. Let's see, so body temperature, childbirth, fever, clotting. Yeah, so which one of those would be an example of homeostasis? Which is a mechanism of homeostasis. Body temperature regulation, fever, blood clotting, childbirth. Which of those four?
Fever?
No, fever is actually a positive feedback, and it's not a part of homeostasis. It's a deviation from homeostasis. It is a...
Would it be
Childbirth.
child's birth? Yeah.
Nope, childbirth is also positive feedback.
Is it temperature regulation?
Thank you. Temperature regulation. Okay. So in order to understand that question, you have to understand homeostasis, how it relates to negative feedback, and how it relates to positive feedback. Okay. Now the body undergoes two mechanisms. Okay. Two types of feedback, positive feedback and negative feedback. They are both a part of your body's function. Okay. Now, negative feedback is going to sense a change and oppose that change, bring your body back to where a set point is. In other words, it's maintaining stable internal environments, regardless of the changes internal or external. And that's why negative feedback maintains homeostasis. Because negative feedback senses a change, brings you back to where you were originally by opposing that change. Okay? Now, positive feedback, again, it is a feedback of the body. It's a normal feedback, but it is not homeostasis. It's not keeping a stable internal environment. Positive feedback is actually an amplifying feedback. So it senses a change and it continues that change and it gets it higher and higher. It does achieve a purpose, but that purpose is not to maintain homeostasis. And that's why positive feedback is something your body does, but oftentimes it is associated with being with a dangerous function or harmful to the body. Can you die from childbirth? Yes. Can you die from having a fever? Yes. Can you die from having blood clots? Yes. Okay. So in all of those three examples, they are positive feedback because it senses a change and it makes that change stronger and stronger. Okay. So childbirth, when the child's head hits the cervix, it causes oxytocin to be released. When that happens, the brain senses the oxytocin and it releases even more oxytocin. So it amplifies the contractions. What's the purpose of that? To pop the baby out. Okay, so there's a purpose, but it's an amplifying and it could be dangerous to the body. Fevers. Okay, our bodies undergo fever when we sense danger from, like, for example, bacterial infection. Because over time, our bodies come to the knowledge that bacteria can only handle a certain temperature. If you increase that temperature enough, you decrease the bacterial growth. And that's why when we have a bacterial infection, one of the symptoms of that is having a fever. So your body senses the presence of bacteria, and it's going to turn off your temperature regulation mechanism so that your fever can build and build and build and build. Okay. If that process goes unchecked, you can die. Okay. So if your body temperature gets high enough, you can die. But it has a purpose, and the purpose is that it's risking that potential in order to reduce the level of bacteria, because it's sensing of those two, currently the bacterial infection is more dangerous. Okay. Blood clotting. If I have a cut, I can bleed out and I'm going to die. So your body goes, okay, what's more dangerous at that situation? Bleeding out or having clots to close that bleed out, but yet that clot could potentially move around and close other areas of your body, of your blood vessel. So it's going to go, I'd rather stop that bleeding right now and risk the potential of that clot breaking off and then closing a smaller blood vessel. Okay. So both childbirth, fever, and blood clotting, they sense a change and they amplify it. They make it stronger and stronger. However, there's a risk overall. So it can be dangerous, life-threatening. But that process, that positive feedback, is a self-amplifying, where negative feedback, okay, maintaining stable internal environments, like making sure that you have a certain blood glucose levels at all times, or making sure your body temperature should be at something, at 98.7 at all times, an average of 98.7. Okay. So in negative feedback, it senses a change and it brings it back to where you were. So it keeps a stable internal environment. Okay. So which of the following feedback supports homeostasis?
Negative feedback because it
Negative.
regulates homeostasis.
That's right. Yep. Okay. Then in addition to that, you have tons of terminology to learn in the intro chapter. Okay, so that's what you will want to spend some time on. Chemistry, there's a lot of you that are really strong in chemistry in this class, and I see it in the videos and the things that you produce, okay? But if you're like me, chemistry was the hardest thing for me. Okay, so I'm going to set aside a lot more time to study chemistry because it just doesn't come easy to me, okay? So with chemistry, you want to make sure you know the terms, which include atoms, ions. Within ions, there's two types of ions. There's cation and anion. How do you tell the difference? What are the differences?
Ions are like iconic bonds. So, oh my God, I need to refresh this.
That's why we're having this review. That's perfect. That's perfect. Perfect. That's what I want you to realize. It's like, as I'm going through this, you're like, oh, I don't remember that. I better review it. Perfect.
Ions are related to like it's an iconic like relationship. It's like a negative and a positive, no? And they
There you go. So ions are charged particles. It could be positive or it could be negative. So which of those terms is positively charged?
I don't know how to say it.
Cations.
Okay.
Cations.
Cations.
Yep. And a good way to remember it is that there's a plus sign in the T.
Okay.
Yep. So cations are always positively charged ions. Like, for example, an atom can be sodium. Okay. Sodium is going to be an example of a cation because you will find that sodium is often written as Na plus. Okay. Because sodium is a cation because it prefers to give away its electron. So, and by giving away an electron, because the electrons are negative, right? So by giving away its negativity, it becomes positively charged. Okay. Anions then are going to be what charge?
Negative.
Yep. Yep. An example of an atom, like let's say chlorine. Okay. Oftentimes you'll find chlorine written as Cl minus. Okay. In other words, it picks up the electron, so it becomes negatively charged because remember, electrons are negative particles. Okay. So it picks up the electron, so then it becomes negatively charged. Okay. All right. What's a molecule?
Carry out the functions of life.
You might be thinking about cells.
2 or more atoms.
There you
Yes.
go. Yeah.
Wow.
Yes.
Bonded
So
together.
yes, 2 or more atoms. And you learned that there are 3, actually there's more than 3, but we only required you to know 3 ways in which molecules form. What are they?
Ionic bond,
Mhm.
covalent bond, and hydrogen bond.
Correct. Okay, so you've got ionic, covalent, and hydrogen. Okay, so make sure you know the difference between those 3. Now, I gave you some examples to do on the worksheets. Okay, so go to the worksheet, kind of walk through them. I also created a video of me going through the worksheet. So if you did it and you didn't quite understand it, you can watch that video. Okay, then make sure you know what solutes are, what solvents are, all the terminology. Okay, these would be great on flashcards or Quizlets if you use that. Okay. Excuse me, still recovering from a cold. Then we have molecules. We talked about it earlier, right? And Ray also put into the chat that molecules are 2 or more atoms. Now, molecules can be stable or they can be neutral. What's the difference between stable and neutral?
Neutral means that it has the same protons and neurons.
Protons and neurons? Say that again. I didn't catch that. I'm sorry.
Neutral means when it has the same protons and electrons.
Mm-hmm. That's right. So neutral means it has neutral, it's neutral in charge. It has a 0 balance. Okay. So neutral just means it has 0 balance. It's not positive nor negative. Versus what's stable?
When the outermost energy level is full.
That's right. Yep. So when the outermost shell and you can say energy level, or you can say orbital. They're all the same thing, is full. And in anatomy physiology, we really don't deal with anything beyond three levels, 3 energy levels. So what's the first energy level? How many electrons does it need to be full?
2.
Yep.
2.
Second?
8.
8.
Yep. Third?
More than 8. Like
We'll say 8 first, and then it does come back, and then it
8.
builds on the 8. So you're right, more than 8, but the first round, it's 288. Okay. And that's why we have what's called the 288 rule. Okay. So that's what it means to be stable. So if it only has 1 energy level, to be able to be stable, it's got to have 2 electrons. If it has 2 energy levels, it needs 8. If it has 3, it needs to have 8 on that third one. Okay. So of these 2, molecules prefer to be what over what? Do molecules prefer to be stable, or do they prefer to be neutral?
They prefer to be stable over neutral.
Yes, sir. Absolutely. They prefer to be stable. Okay. So molecules prefer to be stable over neutral. All right. And that sometimes is what determines what they bond with, what chemical bonds they form. Okay. Now we talked about chemical bonds. We talked about ionic, covalent, and hydrogen. Make sure you can do those examples of it. Okay. Now for pH scale, what is the pH scale?
Zero to 14.
Yeah, exactly. So it ranges from 0 to 14. 0 being what?
the most
The
as
more acidic range. Oh,
Yes, ma'am. And 14 being then,
the most basic.
yep. And 7 being,
neutral.
yes. Perfect. Okay. It's kind of weird because it's technically the reverse of what that value is. Okay. So this P right here stands for mathematically the logarithm of something. So the inverse of something. So the more quantity there is, the lower the number. Okay. So that's what a log means. It's the inverse of something. So the more quantity there is, lower the number. Okay. So if something is really, really acidic, has lots of hydrogen ions, you would think it should be on the 14 end, right? Because that's the highest number. But no, it's the logarithmic value of it. So that means that the more hydrogen ions there are, the lower it is on the scale. And that's why as it reaches 0, that's when you can tell it's the most acidic. Because it's a measurement it's the logarithm of H, and H is hydrogen. It's measuring the number of hydrogen ions. So the more hydrogen there is, the more acidic it is. Where on the scale should it be, high or low?
Low.
Yes, that's exactly it. Okay. Then here's the hard one. In chemistry, this one probably gets students the most, the organic compounds. There's just so many of them, and then so many subsets of them. There's technically only 4. What are the 4?
Lipids, protein, carbohydrates, and nucleic acids.
Yes, that sounds really easy, right? No. Within carbohydrates, there's how many? How many types?
3.
3 types. What are they?
Monosaccharides, disaccharides, and polysaccharides.
Within each of those types, there's how many examples do you need to know? There's 3.
3 each.
Okay. So technically there's 9 altogether you have to know for that one. Okay. So a sample question might be, which carbohydrate can you ingest but not digest?
That was the one we eat that makes like the vegetables tough, no? That makes
This it's a polysaccharide.
Polysaccharide?
Cellulose?
You gotta give me specific, because there's 3 types of polysaccharides.
The
uh,
cellulose.
Say that one more time.
The cellulose?
Yes, that's exactly it. That's the answer I'm looking for, cellulose.
okay.
So cellulose is a polysaccharide that's ingestible. You can eat it, but you can't digest it. And that's why it acts as a dietary fiber, roughage. That is an example test question in the past. Okay. Or I can say, okay, this carbohydrate is the body's form of energy, the most common form of energy in the human body. What would you say?
Carbohydrates.
Starch.
Glucose?
Glucose.
Glucose.
Glucose. Yes, glucose.
Um,
Why is starch not the answer? Because starch is a polysaccharide. It's long chains of glucose. So you have to actually break that down first. Okay. So you have to break down the starch from polysaccharides to disaccharides and then to monosaccharides. So the form of carbohydrate that your body uses is glucose. And essentially it takes all the other forms, breaks it down, converts it to glucose.
Hmm.
And then your body's gonna, here's another test question. Your body stores glucose in what form?
Sugar?
Carbohydrates and sugars mean the same thing. So I want to know specifically what form.
Glycogen?
Yes, exactly. Okay, that is why you can see, and I've only quizzed you on just carbohydrates. I haven't even touched proteins, lipids, which has a lot more than carbohydrates. Okay, so the point of me doing that is to show you the importance of a cognitive map. It's a lot of information. Whenever you have a lot of information that's basically memorization, because this isn't even physiology, right? This is not even how the body works. It's just memorizing this is this does this. Okay. One of the ways to tackle that is doing a cognitive map. Mind you, cognitive maps don't work for everyone, but it works for a lot of people. And the reason for that is because it provides a visual with content or content with visual. So I've created an example of a cognitive map for you. So here I start with carbohydrates. Their function, it could be an energy source, it could be energy storage, or it could be cell structures. Within that, I have 3 types: monosaccharide, disaccharide, polysaccharides, and I listed them there. And this is nice because it's content, but you can visualize it. You can see, oh, okay, I remember in that last column, okay, I had monosaccharide, disaccharide, and polysaccharide. This question is asking me about cellulose, and I recall cellulose is ingestible, but not digestible, and therefore it acts as roughage, dietary fiber. Okay, so having a cognitive map helps you to put all that content into a visible way of seeing it. Okay, I
have a-
would, yeah, go ahead.
For example, in my tests and when we're doing exams, are we able to do that, like speak out loud what we're thinking, or would it flag us as well?
Even if it flags you, I'll just quickly watch it and I'll be like, no, it's fine.
Okay,
She's
because I
just
need to
talking
do
to
that.
herself.
Okay, I need to do that in order to understand.
Yeah, I do that. I talk to myself when I'm taking the test. You just need to make sure that you're not wearing any headphones.
Yeah.
Or earbuds, because that is, you know, we can see that too, so.
Okay, sounds good.
Yeah.
Thank you.
Mm-hmm. Yeah. Other things. Now, there are some cases where there's a lot of distraction around you and you have to wear headphones to be able to block it out. In that case, unfortunately, you can't kind of do both. You can't talk and have like a listening device. So, talk to me. You know, if anything comes up, just contact me. We'll walk through. We'll find something that works for you. Okay. All right. Now, I only did carbohydrates on this PowerPoint. I would like you, if you have time, to fill in the lipids, proteins, and nucleic acid. Do kind of like what I did over here. You did it already in the worksheet, but just do it again. The more often you do it, the more likely you are to remember it, okay? Try to do it without your notes, and then use notes to fill in whatever you're missing. Okay, moving on to cells. So with cells, students like this one a lot because overall it's fun, okay? You're starting to get to something that you can see, you recall from high school, elementary, and so on. For this one, a really good way of doing this is to kind of just draw it out, okay? Draw and label. So do something like this, okay? So I draw out the cell, I label what it's called, what its function is, and then I would pull out my notes and I will compare. What am I missing? Or what do I have wrong? Okay. I will say though that when you did your cytology video, the two most common mistakes that students made was not being able to distinguish between smooth ER and rough ER. Okay, so you want to make sure you can distinguish them and their functions. Okay. So between those two were the two biggest mistakes. Emma, RTA, caught that a lot of you forgot to talk about your peroxisome, so make sure you know about those. I think that's it. Any questions on this?
I have a question.
Yes, ma'am.
So the smoothie R and the rough ER. So the rough ER would be the whole thing that looks like a kind of like a little stack thing. And
Yep.
the smoothie R would have it's different, right? So there's not like there's always gonna be smooth and rough. There's not gonna be like one that is just like ER by itself.
Mm-mm. They
Okay.
have both. Yeah.
Okay.
Some will have more than others. Like for example, your liver, the main function of your liver is to detoxify alcohol and drugs, right? So the cells of your liver is going to have more smooth ER than rough ER, but it will
Okay.
have all organelles.
Okay. And the test would guide ourselves kind of like the lab that we just have to name like the lysosomes and all that.
Yep.
Okay. Thank you.
Yep. Yeah. I think I saw a lot of questions on transportation, so if it's okay, I'll spend some time on that. And then the organelles, it seems like students got that pretty well. So I'm going to spend some time on the transport mechanisms, okay? Now, transport mechanisms is divided to two main types, passive and active. What's the definition between why are they distinguished? Passive is always what and active is always what?
Passive doesn't require ATP and active does.
Very good. No ATP. ATP. What else? One more characteristic.
Some passive, I think, doesn't need a channel protein or something like that.
They can both use proteins actually.
Okay.
Yeah. So passive has facilitate diffusion, which uses the membrane proteins, and active also has the active transport, which also uses membrane proteins. So what's the difference then?
Is it that passive goes from high to low concentration and that active can sometimes go from low concentration to high concentration?
Yeah, you got it. Yay. Excellent. That's it. It's about concentration gradients. Okay. So passive is always going from high to low. So all of these, diffusion, facilitate diffusion, osmosis, filtration, what do they all have in common? They go from high to low. They don't use ATP. What does active have in common? They use ATP and they're always going to go from low to high. Okay, so let's do some examples. So here I have a membrane, okay? Now, of course, when we're talking about movement of things, we also have to determine what can easily move and what cannot easily move. Anything that's small that can move between the membrane itself can easily move, like water, okay? Anything that is non-polar, in other words, not charged, can also easily move, okay? That means that things that are large, that are polar, can't easily move through, okay? So let's say I have water. So I poured water, and let's say I I completely sealed this off. I poured this much water over here and this much water over here, okay? And then I pulled that apart again. So now it has these little holes. What will happen? What will happen?
Osmosis?
Yeah. Water is going to move from what to what?
From high to low.
Yep. So it's going to go from B to A. And is it going to move all the way onto from B to A? Or just to a certain point?
Just to a certain point?
That's right. Until it reaches equilibrium.
Okay.
Okay. So water originally was that red level. Then if I have a porous membrane where it can move, the water is going to move from B to A, but it's not going to move all the way through. It's not going to move to the level where B originally was. It's just going to move over until equilibrium has been reached. Okay. So this is an example of osmosis. Okay, and osmosis specifically is only the movement of water. Okay. Now let's say I had the same situation here. Okay. And now I have particles. Okay. So these are small enough that they can move through the membrane. How is it going to move?
From high concentration to low concentration?
Yep, so from A to B. So will every single particle in A move over to B?
No,
Nope. Only until you reach what?
the equilibrium.
Yes. So this one's going to move over and this one's going to move over. Okay. Now, the reasoning behind that is because here you have all of these particles, right? And they're going to move around each other. And what's going to happen is that I'm going to zoom in. Oh, nope, can't zoom in. So what's going to happen is that the particles bump against each other. Okay, so where it's highly concentrated, they're going to keep bumping into each other. And when they bump into each other, they push each other apart. And they're going to continuously push each other apart until they're equally spaced. Okay, so here's a live example. Let's say you're standing over here. We're in a room. And I'm standing over here. Okay, I spray perfume all over myself. The perfume particles are going to bump against each other and they're going to diffuse. They're going to spread out until eventually you're going to start to be able to smell it. Okay, here's another example. How many of you have made Kool-Aid? Yeah? Okay, so here's water. I pour a packet of Kool-Aid in. Without even stirring, what's going to happen to those sugar molecules?
They're gonna stay down.
They're going to mix out, right? They're going to push against each other and spread out. Yeah, and they're heavier, so they're going to move down. Absolutely. But they're going to spread out. So eventually your water with small chunk of Kool-Aid, it's going to spread out until the whole water changes color. Okay. So both of these are examples of what?
Diffusion?
What kind of diffusion?
Facilitated diffusion?
Nope.
Simple.
Yes. Why? Why simple diffusion instead of facilitate?
Because there's no routine to help it diffuse.
That's right. That's right. Now, if instead, here are my pores, but now here are the particles, it's still going to move over, but now it can't move over, right? So it's got to have what?
ATP.
Protein?
Nope, still doesn't use ATP because it's still moving from high to low. But it has to have a protein that sucks it up and pushes it over. That opens as a gate, to let it through.
And that would
Okay.
be facilitated diffusion?
That's right. This is facilitated diffusion. But note, it's still moving from high to low without requiring ATP. It just needs a protein, like a gate to open and let it through, because it can't move through the membrane itself. Okay? So those two are commonly confused with each other, simple diffusion and facilitated diffusion, and then facilitated diffusion with active transport. So active transport is going from low to high, so it's going against the concentration gradient, and that's why it requires ATP. Where facilitated diffusion is moving from high to low, so although they both require a protein, one's a carrier or pump, the other one's a channel or gate, in facilitated, it does not require ATP because it's still going from high to low. Okay? Questions?
So
All right.
just to clarify, osmosis is water and it
Yes,
stays
ma'am.
at equilibrium. And then simple diffusion is the perfume model where you go into a place and it like spreads. And then facilitated diffusion would be to use a channel protein.
Yeah.
And filtration, we haven't gone over, right? Or
Nope.
did we?
Yep. So let's do that. So with filtration, it's driven by hydrostatic pressure, in other words, water. So driven by hydrostatic pressure. So let's say, how many of you ever made coffee? Yeah? You put the grounds here, right? And then what do? Here's your cup. What do you do once you put the coffee grounds in there?
You pour water over it.
Yeah. And what's going to happen is that the water is going to move through the grounds and it's going to cause it to go through. Okay, so filtration is driven by the pressure of the water to cause the molecule, the solutes to move through. So water is moving through, but as water moves through, it's going to pull the solutes with it. And that's filtration. It's driven by hydrostatic pressure. Okay?
Another good example would be like if we squish a plastic water bottle, the water comes
Yeah.
out.
Exactly. When you squish it, it forces the whatever is in there to push out. Yep. It's about pressure. Yep. Yeah. Now we are on tissues or the histology. So when you're going through tissues, make sure you know the structure and function. There are four main types of tissues, which include epithelium, connective, muscular, and nervous. And of those four, we really focus on epithelium and connective because in future chapters, we'll actually be talking about muscular tissue, like has its own 3 chapters, and nervous has like its own 2 chapters. So even though we do talk about all 4, we do focus on the epithelium and connective. And then when you're going through the epithelium, because there's so much of it, you want one of the ways to study them is just to do a cognitive map of them. And same thing for connective tissue. I do have a chart that you can find on the St. Kate's. It's the navigation that also goes through the same things. Another recommendation I would make for this unit is to watch the supplemental video, and it kind of walks through how you identify them and my tricks. So when I was taking this course, my tricks to kind of how to easily identify one over the other. Like, for example, cartilage is very distinctive in that it has like the owl eyes, bone looks like the cut of a tree, and so on. So there's a lot of strategies, kind of things that help you remember what they are and distinguish them. So I'm going to share, this is a whiteboard that, oh, wrong one. There we go. So this is a whiteboard that I created when I, during my in-class session. So you can see that within the tissues, there are 4 main types. There's epithelium, connective, muscle, and nervous. And you can see that I really spent the bulk of my time focusing on epithelium and connective, okay? So within epithelium, we talked about characteristics. So can you give me some characteristics of epithelial tissue?
It is tightly packed and avascular.
Very good. What does avascular mean?
No blood supply.
No blood supply.
Yeah, and that makes sense, right? Because if it's so densely packed with cells, there's no room for blood vessels, okay? What else can you tell me about it?
It has no.
Sorry, go ahead.
It has no matrix.
Yes, that's right, because it's basically all cells. So that then asks, what is matrix?
It's like empty space, kind of.
It could be, definitely. It could be the space. And oftentimes that space, it looks empty, but it's oftentimes filled with fluid. So what would we call that then if it's filled with fluid?
It's
Ground substance.
Excellent, exactly. So matrix would include ground substance, and it would also include one more. What is that second part?
proteins
Fibers.
Fibers, exactly. Okay, and that's what's characteristic of connective tissue. So where epithelia is so densely packed with the keratinocytes and other epithelial cells, connective tissue tends to have a balance between cells and matrix. And we just established that matrix then would include ground substance and fibers. So that's what distinguishes between epithelial versus connective. Okay, so that's the first step in differentiating epithelium from connective. Epithelial, densely packed cells, no blood vessels. Connective has fibers, ground substance, and cells, a mix of them. Okay? All right. So great. So those are characteristics of epithelium. Those terms that you gave me, that it's densely packed, it's avascular, they differ from if I were to ask you on a test about their function. What would the function of epithelial tissue be?
It covers the lining of cavities or organs, and also like our skin. Covers
Exactly.
our skin.
So, yep. So it covers linings and surfaces. That's one. What's another function of epithelium?
Would it be secretion?
Yeah, that's right. Because it could make up membranes and glands, right? So secretion would be another. Okay. What's another function? Related to its covering of surfaces.
Protection.
That's right. Okay. So protection. And how does it provide protection?
Well, like our skin protects everything inside of our body.
Yeah.
But then like if it's lining an organ, it helps, or a pleural cavity, it helps as far as like the friction and stuff.
Yeah, exactly. So when it provides that protection around like our skin, we call that a barrier, right? It acts as a barrier. So it separates the outside from the inside. So in that instance, it is protection. It's also protective, particularly our skin, because it produces what?
keratin. I don't know how to say it. Keratinocytes.
Yeah.
Yep. So those are the cells. So keratinocytes do produce a substance called keratin.
Keratin.
That coat, right? That gives the skin durability. It waterproofs the skin. Okay. So again, that's kind of a part of its function of the barrier. What else does it do?
It absorbs.
Absorption.
Like UV rays.
Yep. It allows for absorption. Yep. Allows us to absorb substances, but it also allows us to absorb the UV rays so that we can do what? Why is UV ray absorption important?
For
Vitamin D synthesis.
That's right. Vitamin D synthesis. Great. then your skin is also protective in what way? It kind of prevents certain microbes from growing on your skin. So what is that called?
Is it our melanin production?
No, melanin production absorbs the UV and prevents like anything lower from it from being damaged from the UV.
And filters?
Filtration.
Not filtration, nope.
Sensation.
It does allow for sensation, definitely, because you have touch receptors, but this function is particularly associated with protection. So your skin acts as protection in that it produces something that prevent bacteria from growing.
The skin is acidic, so it creates
Yes,
an acid mantle that prevents the growth of microbes.
perfect. Yes. So that kind of is one of the characteristics of skin, right? Is that it has a pH of 4 to 7 because, sorry, 4 to 6. It's slightly acidic, and that's because it produces kind of that acid mantle that protects you against certain bacteria. Okay, great. So those are the functions. Then how you classify and how you name epithelium is based on two things. It's based on the number of layers and shape. Okay, so let's do layers first. If you have just one layer, we call it what?
Simple.
If it has multiple layers, we call it
Stratified.
right. Now, in order to figure out what is what, you have to be able to tell what's the bottom and what's the top. Okay, so you can see that under the stratified right here, okay, I have some where it's sideways, some where it's a top view, and some where it's the top bottom view. Okay, now how would you know that?
You got yourself by the free space?
Basement membrane.
Basement membrane. The first thing I look for is the basement membrane. So epithelium is always going to be supported by a basement membrane that anchors it to another type of tissue, usually to areolar or adipose, but it's usually anchored to another type of tissue. And what separates it, what delineates the epithelium from the other type of tissue is the basement membrane. Okay, so this right here, the dark lining right here, this represents the basement membrane. Then if that represents the basement membrane, I'm just going to put BM for short, basement membrane. Then this then would be the free surface. So from the basement membrane up to the free surface, is there one layer or more than one layer?
Just one.
Sorry, which screen are you sharing? Because I can only see your tissues.
It's the bottom one. She's writing on the bottom corner.
The bottom one?
On the
Oh, I
page,
see it now.
the bottom corner. Yeah.
Okay, I'm like, is it not sharing right? Because I can only see my PowerPoint right now, so I don't see what you see.
It's very hard to see the color that you selected.
Ah, okay. Let me undo that and go with another color.
It's in like the very bottom left corner, over where it says stratified.
What color should I use?
Try red.
Maybe
Red?
red.
Either that or just make your thickness bolder, maybe too. Makes it a little bit
Okay.
bigger.
Let's try with red. So here, is that better?
No.
You see the red? Okay. So this thick line right here, that's in black, that represents the basement membrane. So then when I go up, this then represents the free surface. So from the basement membrane to the free surface, is there one layer or multiple layers?
There's
Just
multiple.
one.
One.
Ooh.
They're
So
stacked up. So that would be one or multiple.
what does the class think?
Well, I mean, like you only see one nucleus, but like, I guess I do see where there's like other layers.
There you go. And that's what you're looking for. So if you're looking at a side view, and if this is the bottom right here, I'm going to shade it in. and I'm going upwards, here's 1, here's 2, and here's 3. So there's actually 3 layers. So from the basement membrane, so it's the side view, right? So here's the here's the basement membrane, here's the free surface. So from the basement membrane to the free surface, you have to count how many layers there are. So in this image, it's showing 3 layers. So from the basement membrane to the free surface, there's 1, 2, and 3. So because of that, this would be considered stratified, okay? And that's the side view. So from a top view, so you're looking downward on it.
I have a question.
Yeah,
You wouldn't count the basement membrane as a layer, right? That's just like its own thing on it
right.
itself, right?
Yep, that's the tissue that anchors it in place.
Okay, thank
Yep,
you.
yep. Mm-hmm. So then if you're looking at the top view, this dark area right here that I'm coloring in red, that represents the basement membrane. Then from the basement membrane to the free surface, and that's the opening, how many layers do you see?
2.
Exactly. So this is another example of stratified epithelium.
And that would be cuboidal, stratified cuboidal.
Correct.
Mm-hmm.
Yep. Yep. Exactly. Okay. So what about the first one then? What would that be? Stratified what?
So it's
Squamous?
columnar.
Ah. So you
I mean, they're
always,
flat, but
so the basement membrane, that's the bottom. So right now you're looking at a side view of it, right? So I don't know if I can flip this. Can I rotate this?
scoot your picture down. It's like at the top where you can't see it. Yeah, do that. And then it should be that little twist. There you go.
So if I were to put it right side up, this is what it would look like. So in a perfect world, you know, top would be top, bottom would be bottom, but unfortunately our tissues aren't like that. And this is what it would look like. So if it was in this orientation, the basement membrane is on the bottom, the free surface is on the top. And when you look at this way, what shape is this?
It looks like columnar.
No, it's thin and flat.
If
I
it's
see
flat, then it's
squamous.
squamous.
It's squamous, exactly. Yep. So the reason why the first time you wanted to say the other way is because it's, instead of being like this, think of it as a sandwich. So instead of a sandwich, here we go. So instead of the sandwich being like this, and clearly it's thin and flat this way, right? You're looking at it this way. So it makes it look like it's columnar, but you only determine the shape based on from the basement membrane to the free surface. So this is the way that the shape is. And because of this, it's thin and flat. So that's why this would be stratified squamous instead of this way. Because if it was this way, then it would be stratified columnar. Do you see the difference?
Yes.
Okay. So the shape is always determined where if you place the basement membrane on the bottom and the free surface on the top, then that's the shape that it takes, not this way. Okay. So the basement membrane always is the bottom and the opening is the free surface, the top. So from the basement membrane to the top, that's where you determine the shape. Okay. All right. Now over here, if you look at this one, here's the basement membrane, the third one. Here's the basement membrane. That makes this the free surface. From the basement membrane to the free surface, how many layers are there?
One.
It's just one. Okay. It looks like it's many because of the nucleus. And what happens is that because this type of tissue has these goblet cells that take up some space, the cells are squished together. And because they're squished together, it makes it look like there's one cell on top of each other. But if you peeled it apart, it really is just one layer. Okay. So as a matter of fact, if it didn't have those goblet cells, This is the goblet cell, by the way. So if it didn't have this goblet cell right here, it would look simple what? What shape?
Columnar.
Exactly. Okay, so if it didn't have that goblet cell, it would be simple columnar. But because this specialized type of tissue, okay, this specialized type of epithelium has the goblet cells and the cilia attached to it, this one is referred to as pseudo-stratified columnar epithelium. Let's take the word apart. Pseudo-stratified. Pseudo meaning false, stratified meaning multiple layers. So it looks like many layers, but it actually is just one. And that's why it's called pseudo-stratified. The shape is still columnar. Okay. And that's why it's called pseudo-stratified columnar epithelium instead of a simple columnar epithelium. Make sense?
So simple columnar only has microvilla. It doesn't
Yeah.
have goblet cells. No goblet cells.
That's right.
And
That's
the
right.
pseudo-stratified has cilia and goblet cells.
That's right.
Okay, thank you.
Very good. Okay. What would you call this one right here? Let's do A.
Are you
That's
pointing to? Oh,
What is it?
stratified squamous.
Stratified cuboidal.
cuboidal.
Stratified cuboidal. That's right. Because you remember, you're looking at the side view where this is the basement membrane. This is the free surface. So the shape that is showing you, I just didn't draw a 3D version of it. So if I did, it would look something like this.
Yeah, if I turn my head, I can see the columns.
Yep. Okay. So A is stratified cuboidal. Now this particular type of tissue can stretch. As a matter of fact, this is an example of what your urinary bladder looks like. So your urinary bladder, if it's empty, it's stratified cuboidal epithelium. And when it's full with urine, it stretches and becomes stratified what?
Traditional.
Squamous.
Squamous.
So flat.
And because it can change shape, this type of tissue is called what?
The traditional.
Transitional.
Transitional. Okay. So with shapes, if it's thin and flat, it's always going to be what?
Squamous.
Squamous. If it's cube-like or where its height and width are equal to each other, what do we call that?
Cuboidal.
Yep. If its height is greater than its width, it's called
Columnar.
columnar. Okay. So when I graded the quizzes, I noticed that some of you had to work on the shapes a little bit more. Okay. So compare the height to its width, and that will always kind of help you with determining what shape it is. Okay. Any questions on epithelial? Hopefully that helped a little bit.
I tend to get wrong the ones that are cuboidal. I mix cuboidal and columnar because I mix them together. Like if I was doing the lab, I would always mix because to me, cuboidal looks more like a circle than a.
It can.
And then I kind of confuse it with columnar.
Yep. So with columnar, the height is always going to be greater than its width. Okay. So whether it's perfectly cubed, like sharp cubes, angular, or if it's round, it's called cuboidal. So that's why this one right here, I drew it kind of a little bit round. Do you see that? So, but still, you can see that the height is about equal to its width. So height is about equal to its width. And that will always be cuboidal.
Okay.
Okay. Where columnar, its height is always greater than its width. Okay.
So cuboidal is, I look for the length equal to the width.
Yes.
And columnar, I look for the tallness.
Yes.
Okay, thank you.
Great. Yeah. Any other questions with epithelium?
Yes.
Yeah.
Could you explain again the pseudostratified, how that has the goblet cells in there?
Yep. Yep. So
Okay.
because the pseudostratified columnar epithelium, it makes sense once you apply it. So within your body, there's not that many areas that have pseudostratified columnar epithelium. Okay. So where would it make sense for you to have lots of mucus and cilia to move things along?
In your mouth.
Yeah.
Digestive.
So a lot in your respiratory system.
Okay.
So you'll find that the majority of your upper respiratory system is going to be lined with pseudostratified columnar epithelium. And the reason for that is because anything that moves through your air pathway, you want to be able to sweep it along, and that's why it has cilia. And you also want to have that mucus to protect and like surround things. Okay. So that's why pseudostratified columnar epithelium is unique in that it has both goblet cells and cilia. Okay.
Okay, thank you.
Yeah. So just kind of, if you connect its function with the structure, that always helps.
Okay, thank you.
Yep.
For the
Okay.
test, do we
Yeah.
have to know like the functions of each epithelial tissue? For example, like where a squam is found and what is the function and all that?
Not at this point, but
Okay.
at this point, you just need to know to be able to classify them and identify them.
Okay.
Yep.
Thank you.
Eventually, when we get further down the line, and as we add more onto kind of understanding how structure fits with function, then you will.
Okay. Thank you.
Yeah. Okay. All right. So now moving on to connective tissue. What are some characteristics of connective tissue?
It has blood.
It's vascular.
It's vascular. What else?
It's widely spread.
Yep. What else?
Consists of mostly matrix.
Yes. Okay. So the characteristics of connective tissue is that it's got cells, but oftentimes it's mostly matrix. And just to remind everyone, matrix means ground substance and fibers.
I have a question about that.
Yeah.
In the slides, it also said it had a lot of proteins. Would the proteins be considered the fibers?
Very good. Yep. Okay. How about its function? What's the function of connective? There's a lot.
I don't know.
The main overarching one is like connecting everything.
That's right. It's true. It does. It connects things. Absolutely. But essentially anything that didn't fit into epithelium, muscle, or nervous got thrown into connective.
Okay.
Okay. So that's why it has such a large range of functions. But you're right. The overarching thing is that that's why it's called the way it is. It's that it connects things. And most of them do connect things, like reticular, areolar, dense, all of those connect things. But you also have some weird ones like blood, bone, adipose. Okay, so there's some oddball ones in there as well. Okay, but essentially you classify connective tissue based on those three characteristics, right? What kind of cells do they have? What kind of ground substance does it have? And what kind of fibers it has. Okay, cell type is very various, and its cell type connect to its function. With fibers, three types of fibers. What are the three types of fibers?
Sorry.
The three types of fibers in connective tissue?
Yep.
Like the fibrosis? Fibers?
Like fibers. There are three main types of fibers. One is really
Yeah.
strong. What's the strong one?
Collagen or collagenous, yeah.
One is very flexible. Which one's that?
Elastic.
Elastin?
Yep. And one creates kind of like a mesh.
Reticular.
Very good.
Yeah. Mm-hmm.
Perfect. Okay. So we oftentimes divide connective tissue into these three main categories. Fibrous, in other words, they have a lot of fibers. Loose, which means they have less fibers, and then others, okay? So fibrous, the ones that have lots of fibers, there are three main types. There's areolar, reticular, and dense. Okay, let's start with areolar. So for each of these types, you want to know a little bit more about them. Okay, so for the connective tissue, you do need to know where they're found, what their function is, okay, and what special characteristics they have. Okay, so we'll start with areolar. Where do you oftentimes find areolar?
And the epithelial tissue.
Where specifically?
I just know it binds the epithelial tissue to the skin.
Well, the epithelium is oftentimes the skin.
Okay.
Yep.
It surrounds blood vessels and nerves.
It can do that. Yep. But oftentimes we associate areolar tissue as a supportive tissue below skin. Okay. So if you have an epithelium here, you have the basement membrane here. Oftentimes what's below that?
Areolar tissue.
That's right. So let's look at skin for an example. We say skin a lot. And sometimes we say it kind of incorrectly because technically skin or cutaneous membrane is made up of two layers. What two layers?
The hypodermis and the dermis. Or the epidermis and the dermis.
There you go. There you go. The epidermis and the dermis. So oftentimes, and I make that mistake too, oftentimes I use the term skin instead of epidermis when I really mean epidermis. So skin includes both the epidermis and the dermis, and then there's the basement membrane in between. Okay. So the epidermis is epithelium. Then you have the basement membrane, and then you have the dermis, and the dermis is mostly areolar. There's other connective tissues in there, but it's mostly areolar. Okay. So that's areolar. Areolar oftentimes supports below the epidermis. Okay, and thus it becomes the dermis if you're looking at skin. Okay. Characteristics of it, it tends to have equal amounts of cells to ground substance to fibers. Okay. Do you look at the picture? Areolar compared to reticular. So you can see that in areolar, the number of cells to the ratio of ground substance to the ratio of fibers are about equal. Okay. That's going to differ from reticular in what way?
Reticular has more fibers.
You got it. And that's the main thing that distinguishes between areolar and reticular. A lot more fibers. Okay. And because of that, that's why reticular creates this mesh. And that's why this type of tissue, this type of connective tissue, oftentimes work as filtering. And that's why, for example, the spleen, which helps to catch damaged red blood cells, is made up of a lot of reticular connective tissue. Make sense?
Yes.
Okay. Then we have dense. There's actually two types of dense. There's dense regular and dense irregular. Now, if you can look at the images for me and tell me, what do you notice? How are they different?
Regular is like super organized, and irregular is just chaotic.
Yeah. Yep. Regular, the fibers all run parallel to each other, so they run in one direction. Where irregular, there's still a lot of fibers, right? But they run in all different directions. Okay. So which one do you think gives me more strength or resistance in one direction?
Regular.
Dense regular.
Dense regular. Okay. Where dense irregular will give me resistance and strength in multiple directions. Okay. So here's my skin. We just talked that the skin has the epidermis, followed by the basement membrane, followed by areolar. And it also has reticular. I'm sorry, it's also going to have a little bit of dense below that. What kind of dense would it have?
Irregular.
Yes, exactly. And that's why when you go to your grandma's house and she pulls on your cheeks, you know, Your cheeks don't sag down, right? Because it resists the pull in multiple directions.
Okay.
Okay? But let's look at ligaments and tendons. Okay? So ligaments and tendons give you really good support in one direction. Okay? So if it gives you support in one direction, like your ACL and so on, your ligaments and tendons, which type of dents would you find there?
Regular.
Regular. It gives you more resistance, more support, more strength in one direction than irregular would. Irregular gives you in multi-direction, but it's not as strong as the regular. Okay? Does that make sense?
Yes.
All right. Then we're finished with the fibrous. We're going to move the fibrous aside. Now, if you compare all of those fibrous to the loose, under loose, there's two. There's adipose and blood. What do you notice in those images?
There's not a lot of fibers.
That's
It's all
exactly
just
it.
cells.
That's right. Cells and what?
Matrix.
Matrix include fiber, so be more specific.
Oh,
Adipose cells.
That's a type of loose, but we're looking at characteristics now.
Ground substance?
There you go, ground substance. Okay, so in adipose, it's mostly cells. All those globular cells right there, do you see like all of this structure is a cell right here. So here's one cell, here's another cell, here's another cell, here's another cell. It's densely packed with these cells. Adipose contains adipocytes. It has very few fibers and very little ground substance. So it's mostly cells. Okay? That's what makes it so distinctive. No one should get adipose wrong. It's extremely distinctive. Okay? How many of you have ever seen like the lava lamps?
Mhm.
You know, where those like blobs just like, you know, move around? That's kind of like what adipose looks like. Okay?
I have a question.
Yeah.
I even asked like my whole classmates because I saw that fibrosis, or I don't know how you say it, fibrosis, but areolar and reticular, they're not loose connective tissues.
No, because technically in order to be loose connective tissue, it has to have limited number of fibers.
Okay.
And because they have either equal or more fibers than other substances, technically they're under fibrous.
Okay.
Yeah. You want to say loose because they look kind of loose, but because they have the amount of fibers that they have, they technically are not classified as loose.
Okay. Thank you.
Yeah. Okay. Then we have blood. Blood is really weird and oftentimes confused because it has so much fluid. And that's why it's hard to kind of imagine fluid being a tissue, but it is. Blood is a fluid tissue. Okay. So in blood, what can you tell me about it in terms of ratio of cells to ground substance to fibers?
The plasma is the matrix.
Be specific. The plasma is not just the matrix, but it's specifically what?
Liquid matrix.
Matrix includes ground substance and fibers. So the plasma would be mostly what?
fibers.
Like the red and white blood cells and the.
So the red and white blood cells would be the cells. Okay. So connective tissue has 3 parts. Right? So it's got the cells. In this case, the cells for blood would be white blood cell and red blood cell. You're right. Then the matrix includes 2 parts, the ground substance and the fibers. So if you look at that, you have the cells and then you have the space in between. So the space in between isn't really space, it's actually a fluid. That's what plasma is. So plasma does have small amounts of fibers, but it is mostly what?
Liquid.
Liquid. And what is that? So what would we classify that as? what component of matrix would we classify that as?
Ground substance.
There you go. Okay, so blood is mostly ground substance, and that ground substance that you find in blood is plasma. Okay. All right. Okay, and blood functions in transportation, so that's how things are moved along. Okay, so that's loose. So pulling that aside, now we're gonna look at the last two. So in the last two, we've got bone and cartilage. Okay, so bone is very distinctive. Tell me, what do you notice about bone in terms of cells, ground substance, and fibers?
I know to identify it looks like a cut up tree.
Yes, ma'am. Yep. Absolutely. What else?
I feel like there's not a whole lot of like matrix to it. It just looks like cells and fibers.
That's a good
It contains
observation.
osteocytes.
It does have osteocytes. Excellent. So the type of cell it has are called osteocytes, where adipose had adipocytes, bone has osteocytes. Now, it looks like it doesn't have any matrix, but it actually does. And why that's a good observation is because the matrix undergoes this hardening process called mineralization. Okay, it does have matrix. As a matter of fact, the ground substance that you find in bone is calcium phosphate. And the fibers that you find in bone is collagen, and that's why bone is so strong. It just happens that the collagen and the calcium phosphate crystallize and hardens, or it mineralizes. And that's why it looks like it doesn't have matrix, but it actually has a lot of matrix. Okay, so do you see all those web structures? All like the circle web structures right here?
Mm-hmm.
Okay.
Yes.
All of that is mineralization or crystallization of the matrix. Then in between them, you see the little dots? The little dots represent the osteocytes. Okay, so that's what bone is. Bone does have all three components, but it goes through a very specialized process of mineralization where the calcium phosphate and the fibers kind of become hardened. Okay, what term do we call that when they become hardened?
Mineralization?
Yes, but we actually have another term for the substance. What is a substance called once it becomes hardened? I'll give you a clue. It starts with an H.
No clue.
I don't know.
Ends in apatite. Mineralized matrix is called what? Yep, I hear pages flipping. Excellent.
The problem is it's not in my notes.
Hey, that is an excellent observation. If it's not in your notes, that means you gotta make sure you're double checking that all the material content in your script, it finds its way into your notes. That's a great observation.
I don't know how to say it. Hydroxapates?
That's right, hydroxyapatite. Okay, so hydroxyapatite, and you can pronounce it whatever you want as long as you can recognize it and spell it. Okay, is mineralization of the calcium phosphate and the collagen. Okay, great. So the point of going through this is for you to recognize what areas you've studied and what areas you haven't studied yet. So if you don't see that term in your notes, you got to go back and make sure you have those terms and other things in your notes. Okay.
What is it called?
All right,
Hydroxy.
apatite.
Okay, thank you.
Yep. And then you have cartilage. Okay. So within cartilage, there are three types of cartilage. What are the three types of cartilage?
Highland cartilage,
Highland cartilage.
elastin cartilage,
Yep.
and There's one more.
Starts with an F.
Fibrocartilage.
Cartilage.
Fibrocartilage. Excellent. Okay. So if I'm looking at my ear, that's cartilage, right? What kind of cartilage is that?
Elastin?
Yes. Okay. In a newborn, actually, maybe because we're adults, so we probably won't find. But in like if you have children in between the epiphysis and the diaphysis of the long bone, there's cartilage in there. What kind of cartilage is that?
Island cartilage.
Island cartilage. In between your vertebrae, what kind of cartilage is that? Fibrocartilage. Okay, so you should know where you would find those types of cartilage. Okay, now cartilage is very distinctive. It's got cells that tend to pair up with each other, and because of that, it looks like owl eyes. So very distinctive to be able to recognize. Okay, all right. Then you have, I remember that there was a request for muscle. So let's look at muscle. So the next thing I want to I'm sorry. Is there any questions on connective tissue before I move on?
So for the labs, when it says cartilage, I think I asked you in the morning, but just to clarify, when it says cartilage in the lab, and then there is hyaline cartilage, because hyaline cartilage has its own, and then elastin has its own, and like that. You would just put like cartilage, right? Or do we have to put like hyaline cartilage, or no?
No. In lab, I'm just requiring you to be able to identify cartilage in general, but in lecture, you have to know the distinction between them because they have different functions.
Yes. Okay.
Okay, but in lab, we focus more on anatomy than on physiology. Okay, so in lab, you just need to tell me that it's cartilage. But in lecture, you need to know where you would find what type of cartilage and what function they have. Okay, all right. So moving on to muscular, because that was one of the questions. There are 3 types of muscular. So you want to make sure you know the characteristics. Oh, my pen's out of power. So you want to make sure you know the characteristics and function of muscular. And a key thing about knowing which is which type is whether it's voluntary or involuntary, striated or non-striated. Okay, so what does it mean to be voluntary versus involuntary?
Voluntary,
Like move on your own.
Yeah, you have conscious control over it. Okay, that doesn't mean that this, for example, your skeletal muscle, you do have conscious control over it. I mean, like you can say move and it moves, but it also undergoes unconscious control at times. It can take over, like your jerk reactions. Okay, but in general, voluntary means you do have conscious control over it. Okay, involuntary means you don't have conscious control over it, like your heart. I will give you an A right now if you can tell your heart to. No, I wouldn't do that. But if you can tell your heart to stop beating,
let me make it stop real quick.
Let me just stab a pin in there.
Exactly. So it's controlled, but it's controlled under unconscious control, okay, or your autonomic system. All right. So your smooth muscle is another example of involuntary. Okay. So of the 3 types of muscle, you only have one that's voluntary. Which one is it?
Skeletal.
Skeletal. Okay. Striated versus non-striated. What does that mean?
Literally, if it's striped.
If it has stripes up and down.
Yep, but I want you to be anatomical about it. What does those stripes represent?
The stretch.
What do the striations represent?
It's not like the stretchiness of it?
It's related, yeah, but give me a little bit more.
Does it have to do with them like contracting?
Yes. That's it. Yep. Okay. So later on, when we get to the muscular system, we're going to talk about the bands the H bands, the I bands, the A bands, and such. So that is related to that function. Okay. All right. So there's two types of muscular tissue that's striated. What are they?
Skeletal,
Skeletal and cardiac.
cardiac.
Very good. So that's two ways in which I've taught you to tell the difference, right? But whether it's voluntary, involuntary, striated, or non-striated. Okay. Now, a third way is that you will find in skeletal. Okay. Look at the drawing in skeletal. It has normally you find a large nucleus right in the center. Here in skeletal, the nucleus tends to be along the plasma membrane, and it's broken out into these parts. And that's why skeletal is unique in that it has what characteristic?
Can you repeat the question?
Sure. So the nucleus is normally round and right in the center of a cell. But you can see in my image right here, it's not. It's not in the center of a cell. It's actually at the plasma membrane, the edges, and it's broken up. So let me show you here. See, my pen works now. So I'm going to highlight, because I drew my cell in red, I'm going to use yellow. Okay, so this is one muscle.
Does that mean it's multinucleated?
Yes, that's the term I'm looking for. Thank you. So that's one cell right there. Muscle cells, skeletal muscle cells are very long. And instead of having a nucleus right in the center, it's broken into parts, and they tend to be found on the edges. And your classmate is correct in that we have a special term for that. It's called multinucleated. So skeletal muscle is multinucleated. Okay? All right. Now, cardiac tissue is specialized in that if you look right here, here's one cell. Okay, so that's one cell. It's shorter and it's branched. See how it's branched right here? Here's one branch, here's another branch. Okay, so that's one unique characteristic of cardiac, is that it's branched. Okay, another unique characteristic is that it has these dark bands right here. These bands that run across cells. And those bands are unique in that only cardiac have what's called intercalated discs. Okay. Smooth is distinctive because why? It's the only one that doesn't have what?
Striations.
You got it. Okay. And we're going to end it with nervous. So nervous, there's two types of cells that you have here, neurons and nerve glial cells. Okay. So neurons and nerve glial cells. Now, is nervous a cell?
It's a tissue, no?
Nervous is a tissue, but is not a cell. So if on a test I ask you, for what type of cell is this? I should not see nervous. I should see either neuron or nerve glial. Okay? All right. We spent most of the hour on this. I don't have a lot of time for the last one. For the integumentary system. So I'm going to briefly go over this because there was one question for it, and that's on the structure of the epidermis. So I'm going to focus on the epidermis, okay? So in terms of functions of skin, you should know its protection. Oops. Know that it's protection, specifically how it protects you, the physical barrier, the acid mantle, as a barrier, okay? Synthesizes vitamin D, sensation, thermal regulation, and communication. All right. So what we're gonna do now is we're gonna focus on the epidermal layer. Okay. So in the epidermal layer, so that's this portion right here. It's broken down to stratums, and stratum is just a word for layers. Okay, so you have the top layer, which is the stratum corneum. You have the net. If you peel that layer away, you have the stratum granulosum. If you peel that layer away, you have the stratum spinosum. When you peel that way, what do you have?
The basil.
Basil or basale or
The
Sounds
salad.
That's
I watched an acronym on Crash Course, and the way they said to memorize it or to help you remember the layers was "Come, let's get sunburned." So
Oh, right.
CLGSB, and you get sunburned on your skin. So if anybody wants to use that,
Can you repeat that?
it says "Come, let's get sunburned." So CLGSB.
Come, let's get sunburned. Yep. Now notice there is an L in here. What's that L stand for?
The lucidium, but that's only in thick skin on the palms and the soles.
yes.
You got it. Okay. So the majority of your epidermis consists of the come, get sunburned. Okay. And then in your palms and the soles of your feet, then you have the come, let's get sunburned. Okay. All right. So for each one of those, you want to make sure you know what cells you find in each one. Okay. Then you also want to know about the special characteristics of them. So for example, where would you find melanocytes?
In the corneum.
in the basil.
In the bacilla. In the bacilla. Yep. And the bottom layer. That's where you'd find melanocytes. Where would you find dead keratinocytes?
In the first layer, the stratum corneum.
The stratum corneum. Very good. Where would you find keratinocytes starting to form? I'm sorry. No, I said that wrong. Where would you find keratin starting to form?
In the basil.
No.
And this
Is it the granulosum?
Yes, that's right. That's why it's called granulosum, because those cells become granulated.
Grainy.
Mm-hmm. Yep. Where would you find keratinocytes?
In the corneum?
They're in all layers.
Yeah.
Oh, yeah.
You must have seen my trick smile. I'm just waiting. And exactly. It's found in all the layers. Okay. So keratinocytes is found in every single layer. Very good. All right. Let me see what else. Let's see. What type of tissue would you find in the epidermis?
the areolar tissue.
Just in the epidermis.
Stratified squamous.
Stratified squamous epithelium. That's right. Okay.
So would that mean, like, obviously stratified multiple layers, squamous is flat. So would that mean most of the keratinocytes are also squamous because they're all flat?
You got it. You
That should be-
absolutely made that perfect distinction.
Woohoo.
So epidermis is the layer. Oh, I keep trying to write on. Epidermis is the layer. The layer is made of this type of tissue. So this is the tissue. And tissues are made from cells, right? That means that the stratified squamous epithelium are made up of keratinocytes.
Of dead, right? Dead keratinocytes.
It depends.
If you're at
What
the
is it?
bottom, that's where they're created. And then as you get higher, they like die off.
That's right.
It's 30 to 40 days.
Yep.
Yeah.
And that's how long it takes for your cells to grow and push the next set up.
Okay.
Yeah. Okay. So that's really great distinction to make between the layer, the tissue type, and then the cells. Okay. All right.
I have a question.
Yes, please.
What type of tissue is made up of the hypodermis?
Perfect. So in the hypodermis, now keep in mind that the hypodermis is not a part of the skin, okay? The hypodermis is part of the subcutaneous membrane, which is different from the skin because the skin is the cutaneous membrane. Okay? So the subcutaneous membrane is made up of the hypodermis layer, which is made up of connective tissue, specifically mostly mostly adipose, some areolar. Okay, but mostly adipose. So if on a test I ask you, what is the dominant tissue what is the dominant tissue type you'd find in the hypodermis? You would say adipose connective tissue. Okay?
Okay, thank you.
Yeah. And then, yep, so here I go through all the layers and the specific things you need to know about each layer. Okay? So kind of go through these bullet points right here.
Will you be sharing this PowerPoint with us?
Absolutely.
Okay.
Yep. Okay. So let's go here. Now we only had time to go through skin. You also want to make sure you go through nails and hair. Okay. And then membranes and glands, because that's all a part of the integumentary system. Then how to prepare for the lab. I highly recommend using the PDF as a quiz. So that's why I normally tell students here, if this is their PDF right here, and they have images right here, don't write the names of the images on them. Write number 1, number 2, number 3, number 4. Make your keys. You have the answers to them, but then you can use this PDF as a quiz. Get a blank piece of paper and do 1, 2, 3, and then write it out. Because that not only helps you to identify, but it also helps you to spell. Okay, it would suck if you knew it, but you spelled it wrong, and I had to take out half a point. So that's why it's really important to practice identifying and spelling it, and you can do it this way. Okay, so that's how you would prepare for the lab. For the lecture, the best, so I survey students a lot, and the students said that the one thing that helped them the most with the lecture is to rewrite their notes. Rewrite the notes. Okay, you have to make sure that you write the notes first and make sure that everything is in your notes, but then you also want to rewrite it and then double check that essentially everything in your script, in the videos, is in there. You don't want to copy the scripts because there's no point in that. It's like reading a book. You're not going to remember everything. So the point of rewriting the notes is to put it in a hierarchy, like Roman number 1, A, B, C, because this helps. This is studying. When you're rewriting your notes, you're actually studying because your brain has to figure out how to file information in a way that it's understandable and a way for you to pull it back out. That's why rewriting your notes in like an outline format is difficult. It's going to take a lot of time, but the benefits really are significant. Okay, you'll find that you remember easier and more information as well. Okay, so rewrite your notes is what I would recommend. Do the worksheets. I have worksheets for every single week, even though I only require them for certain weeks. But there is a worksheet for every single week. Okay, when you're doing the worksheets, if you do decide to do them, use that same worksheet. Do it twice. The first time that you do it without any notes. That's going to let you know, what do you currently know? Take out your script or take out your rewritten notes without notes, and then do it with your notes. And then you're going to fill in what information you've missed. And I would suggest in a different color so that you can actually mentally see what you knew from what you don't know. So that's a way of assessing. And then that way you can focus on what currently isn't, hasn't been stored in there yet. Okay. So writing your notes, using cognitive maps, any active learning, study groups, just don't read. Statistically, if you read something, you're only going to remember it for like 24 hours. Okay, it does not go into your long-term memory. So be active in your studying.